everyone. Today we'll see the topic introduction of boiler and determination of dryness fraction of steam. Now what basically boiler is that we have to know. Okay, so boiler is an apparatus to produce the steam. Okay, so with the help of boiler we produce the steam. And how steam is produced? Whenever the thermal energy released by using the combustion of fuel, maybe that fuel is coal or oil or diesel, okay, from which we can produce the steam. Now that steam is produced, that will be used in the various industries such as sugar mills, chemical or textile industry. Okay, so in that producing mechanical work by expanding it in steam engine in that particular steam turbine. So how it is, we'll see with the help of the basic diagram. Okay, so this is the basic block diagram of the boiler. Okay, so we'll see all the part first, then we'll go for the detailed discussion. So this is the furnace, then there is a boiler, then turbine, generator, cooling tower, condenser, then exhaust gas to stack, or which is called as chimney. Okay, so whatever the gases comes from blue gases comes from the boiler, that goes through that stacks or chimney, and this BFP is nothing but boiler feed pump. Okay, and superheated steam comes from over here. So this is the basic diagram. Now how it works: inside the furnace fuel and air mixture is there, means combustion is there. Due to that fuel I already explained, maybe coal. Okay, so due to that combustion flue gases are produced, and due to that combustion water inside the boiler gets heated. Okay, and as we know that as the water gets heated, after some time it produces steam. Okay, and that steam, producing steam, goes through this pipeline, that is steam pipeline, and that steam is nothing but the superheated steam. Okay, we can differentiate saturated steam and superheated steam. How it is? Saturated steam which holds maximum quantity of water, but superheated steam is more trying to superheat, that is dry steam. Okay, maximum dry steam, that is nothing but the superheated steam. Okay, now that steam goes to the turbine. Before that, here there are the two components, that is the superheater and economizer. So this superheater and economizer is also called as boiler accessories. Okay, which are very useful to improve the efficiency of the boiler or the overall efficiency of the plant. Okay, how it works we'll discuss in the boiler accessories and mounting session. Okay, but before then this steam is produced, that is nothing but the superheated steam that strikes on the turbine. Okay, whenever that strikes on the turbine, that turbine gets rotated. Okay, means what? Kinetic energy of that steam is produces mechanical energy of this shaft. So this black portion, black rod, is denoted as a shaft, mechanical shaft. So kinetic energy is converted into the mechanical energy, and then finally it is converted into the electrical energy through this generator, so from which electricity is generated. So we first produce the steam with the help of boiler, and finally we generate electricity through the generator. Okay, so up to this we'll get the output. Okay, after that as we know that according to the first law of thermodynamics, if we give the 100 kilojoule heat, we'll get the 100 kilojoule output, but it will not happen. Okay, that again we'll see in the second law of thermodynamics. So some should be rejected, that is nothing but the low pressure steam. So inlet to the turbine, that is nothing but the high pressure steam, and here low pressure steam that goes to the condenser. Obviously that is the hot steam, so we have to cool that steam. So how we cool? So that steam again we provide to the cooling tower. Okay, so how cooling tower works we'll see in this diagram also. So this steam or warm water goes to the cooling tower, and that steam again comes in contact with the cold air. That's why that steam or that water becomes cold. Okay, and that again goes to the condenser. So again that steam is converted into the water, and from that boiler feed pump, okay, it is again provided to the boiler. Okay, so in this way this steam cycle is repeated and steam is produced by using boiler. So this is the basic diagram. We'll see in detail how that superheated steam is come, then how economizer is work, and what are the types of boilers. Okay, so in next slide, so this is the detailed diagram. Again, this is the stack, okay, or chimney from where the fuel gases flows. Okay, flue gases are flows. So this is the fuel and air mixture inside the boiler. Now classification of boiler. So first classification is horizontal, vertical or inclined boiler. Obviously if the axis of the boiler is horizontal, which is called as horizontal boiler, and if the axis is vertical, it is called as vertical boiler. And again if it is inclined boiler, then axis is inclined, then it is inclined boiler. So this is the next type, that is the fire tube boiler and water tube boiler. So example of fire tube boiler is Cochrane boiler, Lancashire boiler and locomotive boiler. So what is the fire tube boiler? If the hot gases are inside the tubes, okay, and water surrounds it, it is called as fire tube boiler. Okay, we'll see. This is the example of Cochrane boiler and this is the fire tube boiler. So we can see that this from these tubes, okay, so this hot flue gases, from these tubes flows hot flue gases and water is surrounded it. Okay, so that is called as fire tube boiler. So this is the Cochrane boiler. How it works? Okay, see, first we see the parts. This is the grate, then aspect, smoke box. These are the mountings: safety valves, steam stop valves, pressure gauge, then manhole, then feed check valve, this fusible plug, water level indicator, whichever the portion mounts on the boiler, okay, which is called as boiler mountings. And we already stated in last block diagram, in economizer, then superheater, these are the boiler accessories which will use for improving the efficiency. Okay, now this is the steam portion again. Now we'll see the working. So here furnace, so inside the furnace combustion is there, okay, so burning process is there. So due to that, this flue gas, this is the ash pit, okay, so after the burning process, whatever the ash which is collected over here, okay, in the ash pit, and grate is this portion below the furnace, okay, where the combustion process is done. Now this flue gases flows over here, and this water takes the heat of the flue gases and that gets heated, that convert into the steam. So this portion is nothing but the steam portion, okay. So that steam again goes through the steam stop valve. Before that, we have to measure the pressure, or we can see the pressure of the steam through this pressure gauge, okay. This is the safety valve. How it works, we'll see in the detail, but in one liner I can say that whenever the pressure of the steam exceed below the determined level, in that time the steam is expelled out from the safety valve, okay. Then this steam stop valve control the flow of the steam, okay. So whether we have to provide to the next session, whether that steam partially or fully, so according to that we open this steam stop valve. And here again anti-prime